bit of a tricky search problem, the minimum knight moves. The idea is you have an infinite chessboard. Okay, this thing is really big on all sides, keeps going till infinity. And your knight starts at 0, 0, and you want to get to a specific spot on the board. And using only the knight's moves are you allowed to do so. And if you're familiar with chess, you know that the knight moves a specific way, 2 to the right, 1 down or up, and 2 to the down, 1 to the right or left, and up, and so on. Anyway, the idea here is that you receive a pair of coordinate location for where you want the knight to go, and you need to come up with a way to get the knight there in as few moves as possible, minimum knight moves, right? And at first it might look like, well, I can send the knight off in as many directions as possible until forever, and it'll eventually find the spot. And you might be right about that. But it's not going to finish in a practical amount of time, meaning it could be for a very, very long period of time where we don't actually get to solve this in a practical way. So what we need to do is come up with a specific type of search that encapsulates the area that we want to get to. Okay, so very similar to other breadth first searches, we're going to implement this type of search a similar way. Now, I want to say something that is very important to this, and that is there are far more efficient search algorithms to get this problem done. But in an assessment setting or interview setting, implementing A* is almost always not going to be expected by the candidate. So you need to come up with something practical, immediate, fairly quick, and that usually involves like a breadth first search, a depth first search, or some other type of weighted search that's not as difficult or as complex as A* or Dijkstra. So first, as with most of our breadth first searches in a grid-like format, we want to have the steps that we're allowed to take. And as we know, since we're allowed to move in 8 different directions, we need 8 different types of steps that we're allowed to take. So the way it looks like is like this. We're allowed to move the knight 2 down, 1 to the right, 2 down, 1 to the left, 1 down, 2 to the right, 1 down, 2 to the left, and so on. And we'll do that by saying, okay, 2 minus 1. We'll say 1 minus 2. We will also have minus 1 minus 2. We will have minus 2 minus 1. We will have minus 1 and 2. Let's see, what else do we need? 1 and 2. And we will have 2 and 1. And what are we missing? Let's see, we have 2 minus 1, 1 minus 2, minus 1 minus 2, minus 2 minus 1, minus 1 and 2. We have minus 2, minus 1. We do not have minus 2 and positive 1. Okay, so these are the steps that we're allowed to take. Scene equals set. Now, this is a trick for your breadth first search typically, since we're going to need a queue. We want to not revisit any spots. Okay, so if we've seen them, continue with the processing. Okay, continue with the processing. Now let's initialize our queue. The way that'll look is we have some tuple that is the number of moves that we have made thus far and the coordinate that we are at in the current state. Now what we want to do is say while queue, because we're going to want to exhaust this queue until we've gotten to where we need to be, moves, and chords for coordinates equals q.pop0. Okay, so now we'll have moves are 0, coordinates 0, 0. If chords of 0 is x and chords of 1 is y, that means we've gotten there, return moves. Return moves, right? So we've gotten to where we need to be, and it's a breadth first search, so we've gotten to the minimum, and there may be other methods that or paths that have the same number of minimum moves, but we will be for sure that this is the minimum number of moves since it's a breadth first search. Okay, now for S in steps, as normal, next, let's call it NXTC equals, we'll say chords 0 plus S0, chords 1 plus S1. Chords 1 plus S1, right? That's the direction that we need to move. And this is actually where things get a little bit tricky, right? So in a typical breadth first search that we want, we say if NXTC not in scene, q.append moves, q.append moves plus 1, comma, NXTC. So we move a spot and we include the coordinate NXTC where we are next. Scene.add, also don't forget, the coordinate that we just visited. Now you'll notice I left some space here, and that is because technically this will solve your problem, right? But the problem we're facing now is we haven't really eliminated a lot of the space that we don't need, right? That we don't need. Now imagine you are this knight on this board, and the spot you're looking to get to is somewhere in the top right, or in the bottom right, or in the bottom left, or the top left. Doesn't really matter which of those it is. The idea though is that you want to eliminate the space that you don't need, right? And what we're going to do for practical purpose here is eliminate the quadrants that we don't really need to focus on. Basically, there's no need for our knight to go to the bottom left quadrant in any of those spots if the spot that we want to get to, the goal, the target that we want to get to, is in the top right quadrant, for example. Right? We can allow for a little bit of space, and we'll do that right now. So we'll say if not NXTC 0 is greater than or equal to -2, because remember, the knight can move down 2 spots, or left 2 spots, or right or up 2 spots, right? We need to allow a 2-spot buffer. So we'll say NXTC 0 is greater than or equal to -2, and x is greater than or equal to -2 as well. This will handle for any moves downward, and NXTC 1 is greater than or equal to -2, and y is greater than or equal to -2. Okay, so if not this, and of course we are going to duplicate this logic, but in the event that it does not meet the requirements, we have to minimize our space to be just the quadrant that we want to focus on, where the spot is in. Then we want to continue, no further processing. Now let's go ahead and duplicate or replicate this logic for the rest of the quadrants. 3, 4. And I'll add a little bit of space here so it looks more neat. Okay, so what we're doing, just a reminder, we're eliminating quadrants where the spot is not in. Okay, so now, as opposed to plus greater than or equal to -2, we want to say less than or equal to +2, right? This is for the other quadrant on the other side, right? Less than or equal to +2, all right? And we'll do the same for NXTC 1 and y, NXTC 1 and y, so less than or equal to +2, okay? And now we need to do the opposite of the two of them by saying greater than or equal to -2 and less than or equal to 2. Less than or equal to 2. There are a lot of moving parts in this problem. I really advise if you are kind of new to breadth first search, as I mentioned in other videos, spend as much time as you can becoming comfortable with this problem, because it is going to be these types of techniques are going to be very useful to you for other breadth first search problems. Okay, so now we've updated everything we need to update by saying, okay, I need it to be within the quadrant that spot is in, otherwise don't make a move. And we run, accepted, submit. Outstanding.